All right, let's finish this up. So we made some hypotheses about whether or not the coin was fair. We looked at a sample and we got some data from a sample. So now we're wanting to see if this data is statistically significant. In order to do so, we found the z-score for this data, the number of standard deviations the actual data is away from the mean. Now we want to know how unusual that is. How unusual is it for something to have a z-score of negative 1.28? And this, if you remember, was a two-tailed test. We were looking at that as our alternative hypothesis. So we're not only interested in this, but it would be just as weird to have a z-score of positive 1.28. In other words, if we ended up with more than 50% of our coins as heads. So we're looking for how unusual this is, or what the probability of this is, or better, what the area. That area has a name. That area is the p-value. And in this case, the area is the area in both of these at once, because, one more time, because we have a two-tailed test. So now, that's why I was hassling you about finding the area in tails like that. To find that area, all we have to do is go like this. We look up a normal CDF. We go from, well, it's already set to negative infinity. You can use that for negative infinity if you like. I usually just use negative 1,000 or something like that. Real small number. And negative 1.28. The mean, try that, 0.28. The mean is 0, the standard deviation is 1. We're going to paste that into my calculator. So my calculator says it's the normal CDF from negative 1,000 to negative 1.28 with a mean of 0 and a standard deviation of 1. You might have to put it into your calculator just like this. It's no big deal. It always goes left endpoint, right endpoint, mean, and standard deviation. Press enter, and I get 0.1. So this area over here is 0.1. That means altogether, both of these areas are 0.2. So the p-value is 0.2. We can interpret that to mean there is a 20% chance that I will get a z-score of negative 1.28 or worse, or positive 1.28 or worse. There's a 20% chance that if I flip a coin 103 times, that I'll have a z-score which is as bad as that. So there's a 20% chance that this is not any big deal. 1 out of 5 times, it's not any big deal. So is that significant? Only 20% of the time? Well, actually not. Usually we are going to say something is significant. Usually we're going to say something is significant if the p-value is less than 5%. If something is unusual enough to happen less than 5% of the time by chance, that's going to be what we would consider a significant p-value. So this tells us that this is not significant. What we say is we fail to reject the null hypothesis. It's not quite the same as saying we accept. Let's go back to the original hypotheses. I'm not saying that I know for a fact that this is a fair coin. I'm saying that this is not a bad enough situation to say that I have evidence that this is correct. I'm failing to reject this. That does not necessarily mean I'm accepting it. All right, that does it for hypothesis tests.